Hello, welcome to Earth Engine tutorial 105. In this video, I'm going to show you how to visualize the NetCDF data with just one line of code. And so NetCDF format is a very commonly used format for especially weather and climate data. And so in this video, I'm going to show you how you can actually visualize that very easily. First, let me show you what the output looks like. So this is a global wind velocity data. So if you want to visualize that, you can use Gmap, just one line of code, and then you'll be able to create something like this very easily. Next, let me show you how you can do that. So first, let's go to gmap.org to download the notebook example, so tutorials, and then scroll down to file number 105 and click notebook and click the download button to download this one to your computer, and then you can open using Jupyter Lab or Jupyter Notebook. This notebook uses packages including Gmap and some other optional packages, so you need to install them, otherwise you won't be able to do that. So just uncomment that and then run this line, control enter. You should be able to install all of those, or you can simply just install PyGS. So PyGS include Gmap and all the optional dependencies, so you can just install this one if you want to. Okay, once you have installed the package, then you can restart the kernel, and then you should be able to execute. So first, let me import the library, and so here we're going to download the sample data, and so this is the URL, the NetCDF data ending in .nc wind global. So this will be just a global wind dataset, and so the output file name, we're going to use the same as this one. So you just specify the file name and then use the download file function to download this one. You can specify the input and also the output. Where do you want to download? So this one can be, if you just provide a file name, you'll be downloaded to your current working directory. So refresh, and then on the left side here, you should be able to see the file that has been downloaded to the current directory. Once we have the NetCDF file, we can use Gmap to read the file. So you can use the function read NetCDF and then just passing the file name, you should be able to read the data. And so it will be is an X array data set. So you can look at here, the dimension 181, I think should be 180 to 360. If you want, you can click this one to take a look at this. So the latitude ranging from 90 degree to -90, but the longitude actually is a bit different. So the longitude ranges from 0 all the way to 360, but in order to plot that on the map, we need to actually shift the longitude to -180 to +180, because 0 360 you won't be able to actually display that on the interactive map. So within this data set, it has two data variables, U wind and also viewed wind. So basically horizontal and also vertical direction. So we have like vertical and horizontal. So that's why we can actually map out the velocity and also some attribute information. So the next step, what we want to do, if you want to visualize the data set just using the Gmap without creating a velocity, you will need to use the function, or you can convert to TIFF format. So sometimes if you have NetCDF file and some of the desktop GS, if you are not able to handle NetCDF, you can convert it to GeoTIFF. So this is what this function is used for, NetCDF to TIFF, and then just passing the input file name, the output. So the output, we're going to use wind global.tiff. So here we have two variables, U and V, right? So basically two, you can think about two spectral bands, two bands in the imagery, and the last one is whether or not you want to shift the longitude. As I mentioned earlier, the longitude ranging from 0 to 360. If you set this one to true, it's going to change it to -180 to +180. If you want, you can always press Shift tab on your keyboard to bring up the help documentation so you can read through that. So I'm just going to execute. Take a look, it's pretty quick. And then on the left side, refresh, you should be able to see a wind global.tiff format. Once we have the TIFF file, then you can add that to Gmap. So this function here allows you to add a map, but we have two functions. The first one is add raster, so add the TIFF format, and we're going to select the band. So the band index starting from 1, so basically just the first band. You can specify the palette, basically the color map, and also the layer name, right? So the layer name, and then just use add GeoJSON. So you'll be able to add GeoJSON. We're going to add a country boundary, because otherwise it might be a little bit difficult to see where are those locations. So just shift enter, and shift enter, you should be able to see the file, right? So this is what it looks like. And the color palette we use a cool warm, right? So basically, if you want, you can change that. And the top level, this is the country boundary. So low right corner here, when I hover my mouse, you'll be able to see what the data looks like, right? And if you want, you can turn the layer on and off. So behind the scene, it's just Google Map, and this is how you can add the data. So basically 2 steps. You first need to convert to GeoTIFF, and then you can load the GeoTIFF. But you don't actually have to. So if you just want to load NetCDF data to the map, you can simply just use add NetCDF. Okay. By the way, so I forgot to mention, we also specify layer control equal to true. The reason we did that, because the built-in the new layer control, that one does not support GeoJSON, so you won't be able to see that from here. And that's why if you want to turn the country boundary off, you need to use the built-in layer control. So this is why in here. And the add CDF NetCDF function is kind of similar to add raster. So you can pass in the file name, what kind of variable you want to plot, what's the color palette, and whether you want to shift it. Also the layer name, right? Pretty much the same function as I mentioned earlier. So this is how you can add the NetCDF data directly to the map without having to convert them to GeoTIFF directly, explicitly. So under the hood, it's still being converted to NetCDF so that it can be added to the map. But this is basically just a shortcut that allows you to do that. So, and you can add GeoJSON, you can add other data layers if you want. So the next one is to actually visualize 2 variables together. As I mentioned earlier, we have 2 variables, U and V, right? So horizontal and also vertical. If you put them 2 together, if you're trying to map, then it becomes a wind velocity. So this function here allows you to add that. So add velocity. So we create a map, and then we add the base map, like, so the base map basically to highlight. So the background is just black color. And then so they can see the wind velocity very clearly. The add velocity function is used to do that. So you can pass in the NetCDF file, and also the zonal speed, and also the meridional speed. So those 2 basically just the horizontal and also the vertical, right? You can basically just think about latitude direction and longitude direction. So there are some other parameters, but you can, for this sample data set, you can just accept all the default settings. You should be able to visualize that, right? And then just shift enter, should be able to execute. So now we have this one, right? It's interactive. If you zoom in, you can see more details. Keep that in mind. Here in the northern part, most likely you see clockwise direction. In the southern hemisphere, you'll be clockwise. So it's clockwise here. In the southern hemisphere, northern hemisphere, you will see counterclockwise because of the Coriolis effect. So that's why you see these 2 patterns, kind of like hurricanes, right? Spinning counterclockwise in the north and clockwise in the south. So we can zoom in, for example, zoom in a little bit, you will see the color and pretty nicely. So this velocity is created based on the 2 variables, horizontal and also vertical, right? So if you zoom in, you see more details. Although it's a big lag, but look at this, pretty nice, right? So you don't need to. Also, when you hover your mouse, you also see the label here, the direction, or also the velocity speed, right? So if I move my mouse, you'll be able to recognize that. So this is an easy way for you to visualize velocity data, so wind directions at the global scale, and just 1 line of code, you can get the work done. And then if you want, you can take a video recording, or you can convert this one to an animation that you can share on social media. And here, if you want, you can turn the layer off, right? It might take some time to load up because it's loading the data to the memory and then plot it on the map. Okay, so that's all for this video. I hope to see you in the next one. Take care. Bye bye.